Hello, everyone. Our project title is AI for Autonomous Task Planning and Execution in Real World Software Projects. And the team members are me, Abhishek, and Irshad. So, this project focuses on improving how artificial intelligence can assist in software development by not only generating code but also managing the complete software engineering life cycle in a controlled and reliable way. So this work was done by all of us. So the next slide, that is introduction. To begin with, the modern software engineering still involves a lot of manual effort. Developers spend a significant amount of time debugging, validating systems, and maintaining software quality. Although AI coding assistants such as this GitHub, Copilot, and ChatGPT and all have improved productivity, they mainly help with generating code and they do not fully manage the software lifecycle. And another main challenge is that existing system often fail to maintain persistent traceability, meaning that they cannot clearly track how requirements evolve into task code changes, testing, and deployment. Because of this, autonomous software engineering requires more than automation. It needs coordination, validation, recovery mechanism, and explainability. In real world software projects, reliability and control evolution are essential, which motivates the need of our research. The next slide is problem statement. Despite of all the recent advancements, current AI-assisted software development system still faces several major limitations. One of the major limitation is that the often task generation, where AI creates tasks that are disconnected from original requirements. Another problem is lack of requirement traceability, making it difficult to understand how software requirements are linked to the implementation. We also see uncontrolled regeneration behavior where AI repeatedly regenerates solutions with proper governance leading to inconsistent results. Additionally, there is poor lifecycle visibility. Because of these limitations, the key challenges we aim to solve is how can autonomous AI systems safely manage the complete software development lifecycle while maintaining reliability, traceability, and control. The next slide is research vision. To address these problems, our research vision is to build a lifecycle aware autonomous software engineering framework. So the idea is to create system capable of automatically planning development tasks, generating executable code changes, and running validation through testing. The framework should also be able to detect runtime failures and perform autonomous repair loops when something goes wrong. Most importantly, it should maintain engineering memory and traceability throughout the development process. The next slide is a system overview. Now let us look at the system overview. On one side, we have existing AI development systems such as Copilot, GitHub, ChatGPT, SWE agent, and AutoGen. So these tools provide strong automation but often lack governance and lifecycle control. On the other side, the traditional systems like requirement traceability, matrices, DevOps, automation tools, and project management system provide governance and structure, but they lack autonomous intelligence. So the main observation here is that the existing system generally provide either automation without governance or governance without automation. Our research attempts to bridge this gap by combining both intelligent automation and structured life cycle. Uh, now the next slide, related works. In the reviewing existing research, we found several important limitations in current approach. Many systems rely on single model execution pipelines, meaning one model performs all tasks without specialized coordination. There is often limited collaborations between AI agents, resulting in poor task management. Recovery and validation workflows are generally weak, making the system less reliable when failure occurs. Another key issue is the lack of persistent engineering memory. As a result, current approach provides only minimal lifecycle governance and poor explainability of generated software artifacts. So these limitations motivated us to design a more controlled and lifecycle aware framework. Next slide, Abhishek will continue.
Sure, thank you. So yeah, let's look into the proposed lifecycle aware framework. So current agentic coding system can generate code quickly, but they will struggle with reliability, traceability, recovery, and controlled execution in real world engineering workflow. So the core idea of this work is a lifecycle aware agentic framework that treats software generation as a governed engineering process instead of just prompt to code generation. So the process solution is an agentic AI lifecycle intelligence engine. The framework introduces deterministic governance, engineering memory, runtime, and the recovery workflow, and also the context-aware retrieval. So instead of single model handling the everything, a specialized agent like collaborate across planning, validation, testing, recovery, and the deployment. So the system is like validated. Uh, every execution step is like monitored, validated, and recoverable automatically. So if failure occur, then framework supports like controlled regeneration instead of unstable autonomous behavior. So the main goal is reliable AI assisted software engineering at scale. So moving to the next slide. So this one is agentic AI system architecture. And the process start with the user submitting a software engineering task, and our API layer handles like authentication, validation, and the request orchestration. And after that, we have a scheduler, which which, which coordinates our task execution and distribute the workload across agents. And the next after that, we have agent workers, which perform like planning, code generation, testing, reasoning, and the validation task. Once everything is done, then at last we release the PR to the GitHub for the changes, and the user can also test the preview you know uh, in the application. So the important idea here is that the execution is like treated as a managed pipeline rather than a single LLM response. Moving into the next slide is a multi-agent architecture. So this slide shows how multiple agents collaborate during the software lifecycle. The planner agent decompose the task into like executable steps. The code generation agent agent produces the implementation patches. Then the test agent will write the test for that particular features, and then validation and the review agents will take care. And once everything is done, then it goes to the PR. So then moving to the next slide, which we have is engineering memory and traceability. So one major limitation of the current AI coding system is a lack of like persistent engineering memory and traceability. A job can be done by any agent, but they don't have any memory or any track where you can track down and see the action has been done on that. But we bridge that gap, and we try to the framework maintains like mapping between requirements, generation tasks, and the complete life cycle, how it evolve over the time. And also, the repository evaluation and the state changes are continuously tracked. Also, we have this execution traces improves like debugging and the auditability with the time. And then we have a recovery histories. Recovery attempts are like preserved to avoid the repeated failure patterns. And we have a dependency traces, like dependency level awareness helps like contextual reasoning, and this improves like explainability, lifecycle visibility, and the control generation. So instead of stateless generation, the framework develop engineering awareness over time. Moving into the next slide, which we have is the context aware retrieval engine. So one challenger with LLM-based software engineering is context overload and the irrelevant retrieval. So the system analyze like what our system do is it analyze dependency relationship. It imports the module, help identify relevant execution context. Historical modification improves like contextual understanding. Runtime log, it helps like retrieve like failure relevant information. And then we have this repository metadata. Repository structure and metadata improve the navigation, like how the changes will be applied. And previously also we have like previously modified file, past modification influence the current patch generation. So yeah, the framework like retrieve engineering relevant context instead of like blindly like retrieving the large code chunks. So that makes our system smart. And the next slide is like runtime recovery and the safety. So autonomous system becomes like dangerous when they modify system without validation or recovery controls. Generated patches are like very so in our system we verify before like integration. Also, we monitor the runtime execution behavior. After that, we have a failure classification. Failures are categorized to improve the recovery strategies. And then we have automated rollback. Unsafe changes like can be reverted automatically, which if in case something goes wrong. And then we have policy based execution control. So execution policy restrict like unsafe operation. That's the main goal of it. And then we have like secret and credential scanning. The framework like prevent like accidental exposure of any sensitive data which user has in their repo. And yeah, so this framework like emphasize like control autonomy rather than unrestricted autonomous. So yeah, next slide, Irshad will continue.
Hello. Next slide is like performance evaluation metrics. To evaluate the proposed framework, we define multiple performance metrics focus on lifecycle governance and autonomous software reliability. These metrics include trace integrity rate, regeneration stability, orphan detection rate, lifecycle health index, and explainability score. Together, these measures help to evaluate execution quality, structure, consistency, traceability, and prevention and long-term life cycle stability of the proposed systems. Next slide, please. Next slide is dataset descriptions. For evaluation, we created a synthetic lifecycle aware software engineering database and datasets designed especially for autonomous development workflow. The datasets contain versions, requirement document, generated implementation task, validation record, execution metadata, and trace relationship between software artifacts. These control datasets allow us to evaluate autonomous planning, trace consistency, recovery, behavior, and lifecycle governance under evolving software requirement. Next slide. Comparison with existing approach. Existing AI coding assistants provide strong autonomous capabilities, but generally lack persistence, lifecycle governance, and structured traceability. Traditional requirement traceability matrix system improve governance and documentation structure, but they require extensive manual maintenance and do not support autonomous regeneration workflow. Our proposed framework combined autonomous reasoning with deterministic governance using trace graph, engineering memory, validation, drive recovery, and lifecycle aware execution management. Next slide, please. Benefit of proposed framework. The proposed framework introduced several important advantages for modern AI assistant software engineering. It improves traceability, explainability, recovery safety, lifecycle governance, and autonomous execution reliability. In importance, traceability, externality recovery safety, lifecycle governance, and autonomous execution reliability. The framework also reduces orphan tasks, unstable generations behavior, repeated validations, failure, and inconsistent software evaluation across development iterations. In addition, the modular architecture improves scalability and support large real-world software engineering environment. Next slide, please. Future work. As future work, we plan to integrate enterprise scale development support, distribution, orchestration service, and the real world DevOps pipeline integrations. We also plan to evaluate the framework using large repositories, collaborative software project, and more advanced autonomous execution scenario. Future improvement may include adaptive policy learning, advanced runtime monitoring, and reinforcement based recovery optimizations. Next slide. So our last and final slide is conclusions. In conclusion, this work presents a lifecycle-aware agentic AI framework for autonomous software engineering and task executions. The proposed system combines multi-agent reasoning, engineering memory, runtime recovery, validation workflow, and deterministic lifecycle governance with a ununified architecture. By integrating autonomous AI generation with structured governance mechanism, the framework improve explainability, reliability, trustability, and controlled software evaluation. Overall, the proposed approach provide a more scalable, stable, and governance-aware foundation for future AI-assisted software engineering. Thank you so much. Thank you, everyone.
Yeah, we'll go through the walkthrough also, right? Dashboard walkthrough. All right, so yeah, let me give you a quick walkthrough of the dashboard. So this is just not just a concept, but this architecture is executable. And so the way it works is like any developer can come, operators, and they create the task. They and and developer has to run the task. So it's loading currently. So yeah, so the steps are like once it loaded successfully, yeah, as you see here, right? So let me show the yeah, once this page is loaded, then I'm gonna show like how to input the task, and then we'll show you like how the applications are being built with this framework. So meanwhile it's loading, like there are like some steps like first we have to create the task. uh, yeah, so any task can be created related to the application. So this is the working product which we have developed with this our software. And so let's assume user wanna edit anything, or so this you just have to create the task over here. And once the task is created, users would be able to view all the tasks, and it can be uh, started from here. So as we have ran like multiple tasks in the past, so just want to walk you through how the steps are, because most of the tools they generate the code, but they don't show the steps of what's going on behind the scene. But these tools able to expose everything in a very abstract way. So as you see, user has the capability to run, cancel, or feed any new task, you know. And this is the log for the last task which we ran for we were adding the data engineering project into the portfolio. And this is the log for that. And everything passed test cases and everything. And the steps it ran is these are the steps, all the way implementing, planning, validation, review, and the integration confirmation. Once that is done, then user would be able to view the project over here. This is the small view, but it can be open in a new URL where user would be able to see the changes which they make, in real time. And once everything is done, PR automatically get raised, but sometime user can create a PR form here, and it goes over here as you see the latest changes, and PR gets generated, and you just have to see the changes, accept it, and and push it to the live. So this is this is all about our autonomous agentic SDLC lifecycle software. And yeah, hope you liked it.